Here's the next example for our ambiguous case. We've already done an example where there was one triangle possible, so it's not going to be that one. But we look at the information given. We have big A equals 54, so we put that angle in the lower left-hand corner. Little a is 13, put it across from big A. Little b is 15. I'm going to put that right here again just to be consistent with last example. That makes the angle across from it big B. And then we've got the c's as our last remaining pair. Again, we're trying to find the angles and the sides that are left over here. Now, in this case, if we have two triangles possible, we're going to have two sets of A's and B's and C's and all that. And if we have no triangles possible, then we're just going to stop and move on. So one thing, like last time, is we want to look at the height. The height here is found out by just, again, doing our little bit of trig calculation, 15 sine of 54. So the height ends up being about 12.14, and really we're just looking to see if that 13 is long enough to reach down to the bottom there, and it is, because it's 12.14. So the 13 gets there. Now that means that there's at least one triangle possible, but we want to find out if there's two. So then we think about this angle again being on a hinge, that 13 swinging over here, it is a little less than 15, and so it does contact over here at some point and make another triangle. So the unfortunate thing here is that there are two triangles possible in this whole problem. We're going to find both of those sets, but we're just going to start off by setting up with the law of sines as we normally would. For the law of sines in this case, I would go with the pair that we have established. So I'm going to put sine of 54 over 13, because that's A and A. And I want to find out, let's find out big B, because we know little b and we can complete that one there. So I'm going to do then sine of big B over little b, which is 15. Now I'm going to skip a little bit more of the algebra in this case. What ends up happening if I solve this, if I cross multiply and solve, we end up isolating it to sine of big B equals about 0.933. Now at this point we have to, we're going to be splitting the problem into two places, but we'll just go with the one that we know, just we can do it right in the calculator for now. We'll split it off afterwards and see what happens here. So we're going to start with just the sine inverse of 0.933. Again, we're in degree mode, and it looks like we're at about almost really close here to 69 degrees. So we're just going to call big B about 69 degrees. Just for simplicity, we'll have it rounded to the nearest whole number. Then, if we note the fact that triangle adds up to 180, and we already have 54 and we have 69, that means what's left over for C is 57 degrees. So there are two of our pieces that we need for this problem. Now the other one, the last one, is going to be solved by using the law of sines again. In this case, we're going to have little c, and I'm going to skip the steps there because we've done these finding the sides a number of times. What ends up happening here is we get about, that little c is about 13.48. You noticed I actually put a little 1 next there. I did that by mistake, but it's worth pointing out that this is the first of two triangles, and so I'm going to put a little 1 by each of those to say this is the information I can get for solving it in one way. Now another possible way, if we know that it's two triangles, is to take a look at this B, this big B here. This is 69, but there's going to be another possible angle that in the second triangle, if I swing this one over, it's going to turn it into an obtuse triangle. And what we'll actually do to find that other set is we're going to just subtract the 69 from 180, and that's going to give us the other possible angle that B2, that angle B could be, in this case, 111 degrees. Now if we have that one's 111 and we know that the original is 54, that's going to mean that our other angle is going to turn out to be 15. So two very different sets of angles and sides there, and then once we have those two angles, we can again use the law of sines to find out little c. And again, you'll notice that these are two completely different sets. These are two possible triangles because that's what we found at the beginning. This is, I guess I would say, worst case scenario because you have to do a lot more work there. But again, you might want to pause, go back and forth in this video just to work through the example that you see in the notes that are printed for you.